Greetings and welcome to lesson 1.1 in our Big Ideas book this year, page 4, which our first unit deals on equations. This should be a review for the most part. This unit should mostly be a review. There are going to be some new things in this unit that are essential to our success this year as we are building upon what you learned last year. So this first lesson should definitely be a review. Now, ladies and gentlemen, if you are watching this at home because you missed class and did not get the instruction, then it is so dang important that you read page 4 and 5 and you took down some notes prior to watching this video. It will only help you remember it longer and understand it better. Ladies and gentlemen, so let's get busy. We're going to use what we applied to use the properties of equality. We're going to apply what we learned to use properties of equality to solve one-step equations. Our essential question, how can you find an unknown value in a true statement? So reviewing some of the notes that you should have taken, and if you didn't, then you get them now. You write them in, and if you have to, you watch, you listen, and then you pause when you're done. So first of all, key term, inverse operations. Now inverse operations are operations that are opposite. You need to write this down, opposite. Inverse operations are opposite. Addition and subtraction are opposites. They are inverse operations. Inverse operations undo each other. And since addition and subtraction are inverse operations, when they undo each other, they will make zero. Because adding or subtracting zero does not change the value of the number you are adding or subtracting zero from. The next thing we need to talk about is why and when we use inverse operations. Well, addition property of equality helps us use inverse operations to solve an equation. And the addition property of inequality says, hey, I can add a number, the same number, to each side of an equation to produce an equivalent equation. So I'm going to add the same number to each side. In algebra, that says, hey, I've got A equals B, right? A equals B. Well, if A equals B, then I can add the same number C to both A and B, and it will produce an equivalent equation. All right? Makes sense? Excellent. Now, it's so important, the subtraction property of equality. The subtraction property of equality is the opposite of the addition. And it says I can subtract the same number from each side of an equation to produce an equivalent equation. In other words, if A is equal to B, then I can subtract C this time. I can subtract C this time from both sides, and I will produce an equivalent equation. So those properties of equality allow us to use inverse operations. And why is that important? Because there are two goals, two things we can do to solve an equation. And the first goal for solving an equation is you have to isolate the variable. You have to get that variable all by itself. Get variable all by itself. Okay? So we isolate the variable. How do we do that? We use the inverse operations that we just talked about. We use inverse operations to undo the given operation. And of course, a repeat, addition and subtraction are inverse operations. So our first goal, isolate the variable. And then we need to keep the equation balanced. Wow, how does that pertain to what we just talked about a moment ago? Well, to keep the equation balanced, we use those properties of equality. Properties of equality, which says whatever you do to one side of the equation, do to the other. Because we know if we do the same thing to both sides of an equation, it produces an equivalent equation. So very important in understanding why math works the way it does. All right, so let's do some of that. So we have this equation that we're going to solve. X plus 6 equals negative 5. Now you might be able to do some of this in your head. That's fine. But we still want to practice. Practice showing our work. Practice writing down our steps. Practice showing what we know and why it works. So, step 1 says isolate the variable. We got to get this x all by itself. To do that, we use inverse operations. So right now we're adding 6 to x. What is the inverse operation of that? It is to subtract 6, because that is the opposite. And when you use the opposite, it makes 0. 6 minus 6 is 0. So now I have x plus 0. Okay, so x plus 0 is what? That's right. X plus 0 is going to be x. Adding 0 to anything is that number. Well, we're not done, because we need to produce an equivalent equation, because step 2 says keep the equation balanced by using properties of the equality. So whatever I do to one side, I have to do to the other. Since I subtracted 6 from the first side, to undo, I have to subtract 6 from the other side to keep it balanced. So a negative 5 minus 6 produces a negative 11. So now x equals negative 11. And we're done. Okay? It's a lot to think about. You don't have to think about it once you understand it. Again, y plus 2/3 is equal to 1 and 1/5. Okay, I need to isolate y. I need to get it all by itself. First goal says isolate the variable. How do I do that? Inverse operations. What's the inverse of adding 2/3 to y? That's correct. Subtracting 2/3. And 2/3 minus 2/3, that gives us 0. So y plus 0 is now equal to something, and y plus 0 is always going to be y. And the second goal is to keep the equation balanced. Whatever I do to one side, I must do to the other. So I subtract 2/3 from both sides. Now, 1 and 1/5, for those of you who don't know how I like to solve adding and subtracting of fractions, I like to take and make them all improper no matter what, especially when I have a negative sign anywhere. So I'm going to take this and make 6/5, and I'm going to subtract 2/3. I need a common denominator. I only make it once, and that common denominator is 15. So from 5 to 15 is 3. 6 times 3 is 18. Okay? And then I have 3 goes into 15, 5. 5 times 2 is 10. So subtracting 10. 18 minus 10 is 8/15. All right. So y plus 0 is 8/15. Y is 8/15. Make sense? Outstanding. Moving right along. X minus 15 is equal to 9. First thing I want to do is isolate that variable. What's the inverse operation of subtracting 15? That's right, adding 15. Because x minus 0 is going to be x. And I have to keep the equation balanced, because whatever I do to one side, I have to do to the other. So I add 15 to both sides. 9 plus 15 is 24. So x equals 24. Make sense? If you say those things in your head as you're doing them, it will start to stick. And then it comes so automatic, you're not even saying them in your head anymore. Y minus 4/5 is equal to a negative 2/5. To isolate y, I've got to do the inverse operations, which means the inverse of subtracting 4/5 is adding 4/5. So now I'm just going to say y equals, because I know that 4/5, a negative 4/5 plus 4/5 gives me 0, and I know that the identity property of addition and subtraction says if I add or subtract 0 to any number, it's itself. So I don't need to do that anymore. I know that that's a 0, and I know when I add 0 to y, I get y. And then I have to keep the equation balanced by adding 4/5 to both sides. Well, now I have a negative 2/5 plus 4/5. I know that my common denominator is 5ths, and I know that a negative 2 plus 4 is equal to 2/5. Done. Y is 2/5. Moving right along. S minus 2 times pi is equal to 3 pi. So now we got to talk about terms that we learned back in 7th grade. So we know this negative 2 pi is an entire term. So when I isolate this variable s, I know that the inverse of subtracting 2 pi is to add 2 pi. I'm going to add the entire term. Okay? So that gives me s, because this right here goes away to 0, and the identity property says s plus 0 is s. I know to keep the equation balanced, I have to add 2 pi to the other side. Well, 2 pi happens to be the same exact term as 3 pi, so if I have 2 pi plus 3 pi, I get 5 pi. And I'm done. Ladies and gentlemen, that's the end of our first video. So you have a quick write. You need to write these two equations down, and then you need to solve them. Take a quick break, take a snack, and then come back and watch video number 2. Thank you.